Alright, let's get started. So, types of reactions.
This should have come in the way too. More words.
Say it again.
Let's not talk about those announcements. Alright, so, all we're doing is taking chemical reactions and breaking them down into categories. There's basically 4 types. We're going to have 5, but there's 4 main types, and there's like 1 or 2 extras, so sometimes people throw in. So let's put a 5 at the end of this. And if anybody doesn't get all this, page 338, 339 of the book basically goes over the same stuff that I'm going to talk about here.
Wait, why put 5?
Because there's 5 types.
Okay.
Alright, so number 1, the first type is called combination reaction. So, as the name implies, in a combination reaction, things combine. So you start out with 2 or more things, and they come together and make one thing. So in a very generic sense, we could say there's an element or a compound called A, and it reacts with some other element or compound named B, and they come together to form some compound called AB. That's it. It's that simple. So to give you a more realistic example, let's do hydrogen burning. So it's reacting with oxygen. So I have 2 things that I start out with. I have hydrogen gas. The oxygen's in the air, but it's one of the reactants. And then after the reaction, I have one thing. I produced water. So that's combination. 2 things come together to make one thing. This is like A and B, and this is AB. Next one's called decomposition. And these are easy to remember because the names make sense. Decompose means break apart. So it's the exact opposite of combination. It's going to be, you have some compound, AB, and if something happens, you heat it up or whatever, and it breaks apart. And you end up with 2 separate things, which could be elements or compounds, and they're A and B. So it's the reverse of the reaction. We started out with one thing, we ended up with 2 things. And for the example, I'm going to use the same one I just used here, and I'm going to reverse it. So what that would look like is you take a glass of water or a beaker full of water, you stick some wires into them, and you electrocute the water, and it separates the water. So here's our H2O. We electrocute it, and it separates into hydrogen gas and oxygen gas, which will then be given off into the air, and you can light it on fire if it entertains you. And we go backwards again. All right, that's the first 2. Those are simple. Putting things together, breaking things apart. Third one's called single replacement. All right, so here we're going to start out with some sort of compound. Let's call it AB. And then we're also going to have something by itself, probably just this individual element, and that's C. And what's going to happen is C is going to replace A. Well, it could replace either one, depending on the situation. And so in this case, it's going to replace A. So we end up with CB. So C stole A's place. It took A's partner. It reacted with B. And then A is given off by itself as a separate thing. And actually, I don't like this one that I did on here. I'm just going to change it. Oh, we'll do this one. So let's say we have, no, we're not going to do that. Let's say we have magnesium metal, and this reacts with copper chloride solution. Okay, so this would be like in water, this is a salt. Now what's going to happen is the magnesium is going to take the place of the copper. So we're going to end up with magnesium chloride and copper metal by itself. Yeah, it's kind of like somebody stealing somebody's wife's sort of, I guess.
Did that happen? You used that white cube so soon?
No. All right, everybody's got the first one, right? Okay. All right. Well, if you want to think of these as couples, the next one gets even more interesting. This is called double replacement. And so this is where we have 2 compounds, and they basically switch partners. So let's imagine we have one compound called AB, and another compound called CD. And they're just going to switch ions usually. So like let's say A is a cation and C is a cation, so they're just going to switch. So we'll end up with CB plus AD, two new compounds. And these tend to look pretty big, but basically when you're looking at reactions and you're trying to classify them, if you see one thing and then a compound, like an element in a compound, that's usually going to be single replacement. If you see two compounds, that's going to be double replacement. For example, let's say we have K2CO3 plus barium chloride. Okay, so here we got two, I should have two here, right? Okay, so we got two separate compounds, and what's going to happen is they're going to switch. They're going to switch cations. The potassium is going to go over here with the chloride, and the barium is going to go with the carbonate. So
they exchange partners.
they exchange partners. It's kind of like
Switching boyfriends with your best friend.
exactly. That's what it's like. So this is sort of the Jerry Springer of chemical reactions.
So annoying.
And I screwed something up. Barium's plus 2, right? There should be 2 carbonates. And potassium gets the chloride, right? Good. Yeah, that's good. Okay, there we go. So yeah, the barium and the potassium switch partners. So that's double replacement. And then there's one more, and this 5th category sort of doesn't fit in because it's not generic like the rest of these.
Combustion reaction.
Combustion reaction. And so,
Red book.
yeah, not everybody counts this as a class, as a type of reaction, but our book does, so I'm going to put it in here. And there's one other that's in there sometimes. Some books will have neutralization reactions. All right, so this is combustion reaction. So this is actually very specific. It can't just be anything reacting. It has to be some hydrocarbon. So you'll see CH, and they'll have whatever numbers. So I'm going to put a little N here for both of these. Anytime you see N, it just means whole number. It could be 1, 2, 3, 4, 5, can't be a decimal. So any hydrocarbon, CH4, C2H6, whatever, plus oxygen. And these two are always going to yield the same 2 things. What is made when you burn a hydrocarbon? CO2, right? Carbon goes with the oxygen, makes CO2. And then the hydrogen also goes with the oxygen and makes H2O. So almost every fire you see is always going to make carbon dioxide and water. And so, I mean, I could give you an example of this, but it's going to look like that, right? It could be C2, all right, let's do C4H10. So that's butane, what's in a lighter, right? When you light the lighter, it reacts with the oxygen in the air, and that produces CO2 and H2O. There you go. And if you ever doubt that there's water coming out of the fire, you can just take a lighter. Here's a lighter. There we go. You can take a lighter and stick it inside of a glass or something, and what you'll see is, there we go, what happens? It starts to fog up, and so there's water in there. So you can also show that there's carbon coming out of here. If you cool the fire while it's still burning, you'll see that what happens is, I don't know if you can see that or not. Yeah, it starts getting black. So I'm actually stopping the reaction before the carbon burns, and I'm just getting pure carbon on here. That's what soot is. But if I didn't cool it with the glass, it would have turned to CO2. You can't see CO2, but I can show you the carbon before it burns. All right, so that's the 5 questions on that. You good?
Worked great.
All right. Thank you for doing the honors.
Hate to find your thing.
Yeah.
Are you guys friends again?
Stop.
So no, really took a flight to